Hey, it's Jason with Novice Attempts, and I've got an update for the Hackerbox 0009 Virtual Worlds project, the Inertial mouse. I wanted to make sure that my mouse was wireless through the Bluetooth module, the HCO5 module. So what I've got here is I soldered on, you can see the headers on my Arduino Pro Micro. I've just soldered on the TX, the RX, the ground, and a couple of other pins on this side, and just the power pins on the other side. I also soldered the last pins just for stability while I was soldering the rest so that I could get the headers on straight. I just did this so that I could test it with a little bit more stability rather than using jump wires like that had a little bit of problems making connections between the board and the breadboard. So this seems to work really well. There's no problems in me having to press down the jump wires to make sure, or twist the board to make sure that they get a good connection. You can see that I have set up a voltage divider on the receive pin of the HCO6. This is just three 1K ohm resistors, one going from the transmit pin of the Arduino to the receive pin of the Bluetooth module, and then two of the same size resistor, they're all 1K, going from the receive line to back to ground. Now, you probably don't need this. The output voltage from the transmit, because this is a 5 volt board, is 5 volts, and this board is a 3.3 volt. But I was running it initially before I read about that, and it didn't seem to do any damage to the Bluetooth module. I'm probably going to keep the resistors just for longevity and assurances. But you probably don't need it. You can probably get away without it. So my connections are just from the transmit and receive on the Arduino to the transmit and receive on the Bluetooth. And then we've got the power. Those jump wires are for power running the rails on the breadboard. And then power, VCC, and ground on the Arduino. And when I hook up the battery that I'm going to be using, you want to make sure if you're over voltage that you hook up the battery to the raw pin, because the raw will do the voltage adjustment from whatever your source down to the 5 volts that the board takes. If you plug it into VCC or something else, you could burn out the Arduino. So make sure you plug your power into the raw, and the ground will return to your battery power source. So my next step, well, let me show you how this is working. It took a while for me to get communications between my computer and the Bluetooth module, and that's because with the Arduino Pro Micro, it initializes the pins on the side differently than it does the USB out, the built-on serial communications. So normally you just initialize serial and set it to whatever baud rate that you need. But with an external module, either an external serial module or in this case our Bluetooth module, we need to initialize serial 1 as well. And I know a lot of people on the forums, on the Instructables comment section were having troubles with this as well, and I learned the solution from the Instructables page. So what I did initially was I just downloaded an Echo program for the Arduino, just so that I can test that I'm getting communication through the Bluetooth module. So first thing I did was I paired it to my computer. You can see HCO5 is connected. And then going to more Bluetooth options and the COM ports, you can see which COM port your Bluetooth module is connected to. The one you want all communications going through is that COM25, the outgoing device B one, at least on Windows. I'm not sure why there's two showing up here. I'm not sure exactly what the COM26, the incoming one, is, but everything seems to work with just the single COM port using the outgoing port here. So let me show you the Arduino code. So you got the setup. I'm initializing serial and serial 1 to 9600 baud. I probably don't need to set both of those. I probably just need the serial 1. Then it's just, when it initializes, it's printing some text, and then it goes into the loop, and it's looking for while it's available. So if it's not being used, it's going to print the just a blank line, and then it's going to say, I heard you say something. So, and then when it is available, it's going to read from serial 1 and then write back what it read to serial 1, and then print another space. So if I upload this, it'll reinitialize. So I've downloaded TerraTerm. It's just a COM port communication program. It's a various communication program. You don't have to use this. You can use PuTTY or anything else that can read and write to a serial port. So you can see that the text is showing up there. That's the initialization text. And then I can just type something. Come on, I need to click on there. So there's no buffering with this module, so it's reading as fast as I'm typing. If I copy and paste, so it may buffer a couple of characters before printing it out, but you can see that it is reading my inputs and echoing back my inputs. So you can see I pasted "what up," and it echoed back some of the characters, and then it buffered some. So you can see that it is receiving data, and that's the important part. So my next piece is to rebuild my circuit with the motion controller and get this to work over the Bluetooth. And then after that, it's going to be removing the USB and powering via probably a 9-volt battery. I wired up the motion controller, and you can see I took out the voltage divider, and I've got it hooked up to a battery. So all the communication is flowing through the Bluetooth module. And as you can see in my Terra terminal, it is recording my mouse movements. So if I pick this up, I will drop the battery and disconnect everything. But it's working there, it's just not moving the mouse. So the mouse library is not feeding via the Bluetooth module. So that's the next thing I gotta check out. I've got some bad news. In the last clip, you saw me receiving data from the motion tracking unit, but it wasn't moving the mouse, even though it was receiving the data over Bluetooth. So the reason that's happening is the computer is not recognizing this device as a human interface device. Apparently you can flash the firmware of the Bluetooth module to a different component's firmware. There's a video on how to do that, but it's very complicated. It involves running a pinout to the various pins on the sides there, and then flashing it using a serial cable to your computer. Sorry, not a serial cable, a parallel cable. It's interesting and complex. I'm not going to do that. You can, however, purchase another Bluetooth module which has the same firmware. It's the device that you would be flashing this to. And what you're looking for is the RN42 module. I found it online here, so you can see that it's the RN42 module there. This is the chip that's soldered on to the breakout board is the RN42. This is a WRL12577. And everywhere I've found it has been around 25 bucks. I don't know if I'm going to purchase this. I might, just to play with it. I don't want to flash my current Bluetooth module just because it seems like a pain. So it looks like the glove isn't going to work wirelessly without something that's a Bluetooth human interface device module, which our HC05s are not. Sorry for the bad news. The other thing you could do is you could write a program on your computer that monitors the serial port that the Bluetooth is connected to, reads the text input from that serial port, and then moves the mouse based on that. And that's probably cheaper, but it's more coding than I want to do. I probably could make it, but I don't want to take the time. So I'm going to put together the glove with the components leaving out the Bluetooth module and just using the motion tracker and the Arduino and the buttons. And I'll show you what I've come up with there. If I do swap out the Bluetooth for the human interface device Bluetooth, I'll make a follow-up, or I'll edit this video to include that information. On the glove, the motion tracker should be in this orientation with the holes on this side when all the components are on the top. So you can see the little silk screen here showing the XYZ, which indicates you want Y, X, and then Z in the middle. So I want it in this orientation somewhere on the back side of my hand and not in the way of this zipper. I also want to orient the Arduino in such a way that the cord coming out of here isn't going to interfere with me. So I definitely don't want it this way where the cord's coming towards my hand, and I definitely don't want it oriented this way where the cord's coming across my hand. So that leaves either like this or like this. And I think actually coming off the back side of my hand, the back side of my hand is going to be more comfortable, rather than having the cord coming up my hand. So my thought currently is to orient them like this, because this gives me, a short run here and here, and then these ones are a little bit longer. And then I'm going to have the buttons coming off the top side of this as well, which will give me a little bit of a nicer run up to the fingers. So I've got the two main components soldered together, wired together, and I'm just going to give them a quick test, make sure that my orientation is good, make sure that it's all talking together and that my solder joints are good. So I'll just plug it in, and you won't be able to see it, but I should see the mouse moving wherever my mouse is. There's my mouse. And it looks like it's working, so currently this orientation is correct. Pitching this way moves the mouse that way, the direction of the hand. This way also moves that way. This going down, pitching down, moves the mouse up, and pitching my hand up moves the mouse down. So I might want to invert that axis so when I lift my hand up, the mouse goes up instead of down. And that's easy enough to do in the software. Just make the y-axis, if it's a negative number, make it positive. If it's positive, make it negative. Basically just multiply by -1. So I'm going to mount mine fairly low, just because that feels natural. Right there. So right at the seam, or right above the seam, seems natural. That doesn't want to stay glued. Interesting. I might have to come up with another way of attaching these. Apparently hot glue doesn't want to stick to that rubbery bit. We'll see if this one fares any better. It looks like it might. So they mentioned epoxy, and that actually sounds like a good idea. So I'm gonna go get some. Okay, I'm gonna rough up the glove with a little sandpaper to help the epoxy stick. It looks like this other one stuck just fine. It's just this rubbery material that's having a problem. So it's roughed up a little bit. I'm not sure if you can see that very well. Yeah, there you go. That should be enough for the epoxy to hold. The epoxy worked great on the index finger. That's not going anywhere. The hot glue worked fine on this material with the rubber just in the stripes. I put a little dab of hot glue on the back to secure the wires in the back. And I was thinking I might not want to permanently attach these. So what I'm going to do is I've got these jump wires that have the little peg in them, and they fit just fine into the receiver pins here. And it's a fairly snug fit. So if I chop off these wires and solder the back of them to my Arduino, I'll have a disconnection from the glove so that I can take off the Arduino and the motion tracker from the glove if I want to do improvements like hooking up the Bluetooth module if I get the one with the human interface firmware on it. So I have my button headers on, and those will socket nicely into the receiving pins. So now I just gotta combine my grounds so they can both interface here. And then maybe shorten. I might just leave it. And that should do it. Check it out. So motion tracker, Arduino, my removable button wires, buttons, click. No freedom of movement loss. These are a little long, but I think they'll be okay. I can always shorten them later. Yeah, let's give it a test. The Velcro on the Arduino is not holding really well. I'll probably have to hot glue that, probably because of this cord is too, puts too much pulling force on it. I've got a screen and notepad with just a whole bunch of X's. This way I can show you that the mouse is moving and I can highlight text and that I can right click. So that should be all the features of the glove. There we are. So yeah, I'm gonna have to reverse the axis on it because that's not intuitive for me. So I'll show you it clicking and moving as I tilt my hand up and down. And then I stop. And it's hard to find the mouse when it's just an eye cursor. So then I'll show you the right click. You can see it dragging. Where's my mouse? Wrong screen. So you can see it dragging the menu around, which isn't fun for everyone. Oh, I could just tap it, I guess. Yeah, that works better. So it's a fun little project. A little disappointing that the Bluetooth didn't work on it. But it's still interesting. It'll take some getting used to. I think I might change the code so that I can maybe put another button on the glove so that I can set where the resting location is and just do a transform on the data coming from the controller so that I can have my hand sitting in a more natural resting position and have the mouse not be moving. Because right now it has to be level in all directions for the mouse not to move, any side to side, front, back. off of, you know, strict flat plane causes it to move. And generally my hand is going to be tilted back, and probably a little bit to the side, so it's going to be wanting to drift to the lower right corner naturally, and I might mess around with it. I don't really have any good applications for this right now. I might try to find some VR stuff that I can play with my new glove mouse. So thanks for watching. It was a lot more discovery than I thought it would be. Discovery about the Bluetooth module, spent a lot of time with that. Just getting like the motion tracker working and outputting to the serial monitor was challenging for me, but I'm glad I did it. I'm glad I stuck through. I learned a whole lot in this project. So if you like this video, please like, comment, and share my video. Subscribe to my channel. Leave comments on the hacker boards. If you're not a subscriber to Hackerboxes, I highly recommend it. These projects are amazing, and you learn a lot. Sometimes they can be frustrating, but they're very cool. So thanks for watching. I'll see you next time. Bye.